Hello all, I'm Shrikant Mane. Today we are going to demonstrate one of the IBM code patterns by name Performance Evaluation of Machine Learning Models. In machine learning world, numerous models are being created for achieving a specific task. With so many models available, how can one decide which model to use? Which model is performing better? What are the various performance parameters for different models? So this code pattern shows you a way to compare Watson cognitive service models so as to decide which model performs better for a particular set of data. It also provides user a platform to configure models, provide input data, execute, and prepare performance evaluation statistics such as confusion matrix and ROC curve. After going through this code pattern, you should be able to create and deploy Watson service models, configure model validation workbench to compare specific models and provide a test data. Also should be able to understand model evaluation parameters and know which model best suits your needs. This is also deployed in the GitHub, and the URL is github.com forward slash IBM forward slash model hyphen evaluation hyphen workbench. Here is the high level architecture of the performance evaluation of machine learning models. And we have various cloud network, Watson Cognitive Services, NLC, Conversation, NLU, Discovery, Retrieve and Rank. And for the purpose of the demo, as I earlier mentioned, we will be using only NLC, the Natural Language Classifier. So the steps are clearly documented. So in order to deploy this, we need to follow these 6 steps, out of which the first one being the prerequisites, for which it says about we need to have a IBM cloud account to to execute this code pattern. If you do not have an IBM cloud account, you can create a 1-month free trial account by clicking on that URL. Just click on the here link. You will be able to navigate to the IBM cloud console, and we need to create the cognitive models for this pattern. To demonstrate, we would be creating and using natural language classifier models. This code pattern requires at least 2 NLC models to compare and evaluate. So we will create 2 classifier models in 1 NLC service instance. So follow the instructions from the given link. You should be able to create the models for each. The first model, when you are creating, use the first data set, NLC underscore training data set 1 for training the first set of the model, and for the second set of the model use NLC underscore training data set 2 for training the second model. And once you are done with training, ensure you have the username, password and the classifier ID or the model ID. Save it in a text file. The classifier ID differs from these 2 models, but the username and password will remain the same. So these credentials are required in later steps. So now that we have created and trained 2 models in 1 NLC service instance, we are ready to deploy this application on IBM Cloud. So there are two ways you can actually deploy. One, you can actually deploy to IBM Cloud or locally. So if you want to execute, if you want to deploy to cloud, please use the step 3 for deploying on IBM Cloud, and step 4 to deploy locally. And here are the steps which has been clearly documented. So once the application is deployed on the cloud, open the IBM Cloud Console. Under dashboard, you should be seeing the application being deployed and running. Let me show you from my screen here. So I have deployed on the cloud, and you can see the application is being deployed under IBM Cloud Console. The URL is console.bluemix.net, and here is the Workbench Model Eval Pattern 2. So I'm just clicking on this. This should be able to launch our application, but before that we need to also configure certain parameters. So cognitive model evaluation application is now deployed. This application now needs details of the model which it needs to invoke for comparing various models. Now, before we launch the application, we have to configure the two NLC models that we have created using different data sets. So the dashboard now we are able to open and click on the runtime tab on the left hand side. You have something called as environment variables. Tap on that. The moment you click on that, you should be able to see the VCAP services. This is nothing but where you actually key in your model details. Let me show you from the document those details. So this is very similar to what I have done. I've just clicked on the model pattern 3, which is the running application, and before we even visit the app URL, we need to configure the model details, the credentials that we have actually saved it in the text. So ensure that you have it handy right now. So once we click on that runtime tab, on the environment variables tab, you should be able to add by clicking on the add button and use these text nlc username underscore username underscore config1. Give the username that you have already copied from in a text file, and similarly the password and the classifier ID. For this is for the first set of the model. Similarly, for the second set of the model, give the classifier ID as different, and the username and password will remain the same. Now the application will restart once we have these environment variables set and saved. We can skip step 4 and go to step 5 to run the application. The step 4 is to deploy the application to local machine. So when we deploy to the local machine, it is specific to one single user, whereas when we deploy to IBM Cloud, the, the same instance, we can have multiple users accessing it. Okay, running the application. Now that we have created two models using NLC, now we would evaluate which model is performing better when compared to each other. So on the application homepage, we can click on the NLC box. So let me go to the application which is deployed on IBM Cloud. So I would be clicking on the NLC evaluate model box, the NLC box. Select model 1 and model 2 checkboxes. To browse, you see two browse buttons will be available. Since we have selected two models, click on each browse button and select the files as NLC truth file, and similarly for the second browse button. Because this file is the actual results file which needs to be compared with both the model results. Now you can click on the evaluate performance. So the application invokes both the NLC services, gets responses, and displays various evaluation parameters. Now you would be seeing the output of it in the form of results. So we can actually analyze the results as well over here. So the results of running the two NLC models using the truth file enables the application to check how the results from each of the models are faring. Now it takes a few more minutes. I think now it's done. As you see, When I click on the recommendation in model 1, I see it says the rating as excellent, and I also see the optimal threshold as zero point 0.9 and maximized F1 score as 98.18. And when I click on the second model, and I see that it is giving me the optimal threshold as zero point 0.1 and the maximized F1 score as 62.34. So when I compare between them two, I think the model 1 fares better than the model 2. And the application also shows ROC chart for both models for various parameters. If I click on summary statistics, you can see the accuracy is 98.15, F1 score as 98.18 for the first model, and for the second model it's 46.3 as accuracy and 61.33 as F1 score. So in this case we can see that the model 1 fares better compared to model 2. Users can now analyze various parameters and can take appropriate decision. Thank you so much.